Don't let it fool you, even if it's black and white, it still flex. You don't have to paint. Yeah, you don't have to do any extra finishing steps. Stiffening layers. Yeah, they took inspiration from leads.
It's really like volume production. So we're not talking about prototyping anymore.
Was so impressed with the work that you have. I would love for you to tell us a little bit about the story of the company and how the things have been going for you guys.
Yeah, sure, with pleasure. So Bcomp, we are Swiss clean tech. We've been founded in 2011.
Okay.
So it's been a few years now, and we're kind of the leader in natural fiber for sustainable materials in high performance applications. So it goes from sports, motorsports to automotive. That's flax fiber. And you can use it in different applications. So they started in sports, and yeah, as I said, and they move into motorsport because it's a very good way to start the material with and to test it. It's really like impressive because it can have a weight-to ratio compared to carbon. It's very interesting.
Really good, yeah.
We've been into motorsport. The material were very well accepted, and now we've moved into automotive. So for when you would like to have an impact, you need to think big. And that's why you need to go into automotive interior, because that's where the bigger impact will be. If you're looking into a new car, you can buy a Cupra Born, for example, and get this beautiful seat with natural fibers. So this one is the same weave as this one, it's just tinted.
Yeah.
It's black. This is for Polestar, for example. So that's all cars that are on the streets at the moment. So it's really like you can
production,
in production. So it's really like volume production.
Okay.
So we're not talking about prototyping anymore. Here you can really like reduce weight by 50%, reduce CO2 by 60%, and plastic by 70% because you replace plastic parts. And now we're into, mass transportation as well, because talking about bigger impacts, it's talking about public transport as well. So talking about rail, trains, buses, metros,
The surface transport.
and aerospace.
Very cool.
So like
and aerospace.
And aerospace as well. So we're working with Lufthansa Technik as well for interior panels of planes. That takes longer, but that's currently on the pipeline.
That's amazing. Gabriele, really nice to meet you, man. My pleasure. We spoke yesterday, and I've been trying to manage my excitement, but tell us a bit more what happened from Bcomp point of view. You started with this, which is...
It started with GT3 and GT4 competitions. This is one of our most recent projects in motorsports. But it's a good example to show and prove how we move from motorsports and very high demanding industry segments, where you really need to push the limits. So we had to combine natural fibers with epoxy.
Very cool.
To compete with carbon fiber and glass. But then whenever the volumes became higher and you need to target needs of industries like mass production of automotive parts, specifically in the interior of the cars, of course, thermoplastics are the game to play. One of the first parts and companies we work with in thermoplastic is with Polestar. Here you can see seat backs coming from the Polestar 3 and Polestar 5.
Okay.
There's a signature weave that we developed for Polestar specifically. Don't let it fool you, even if it's black and white, it's still black. So we wanted something unique that could be linked to their brand. And all their interiors are like this combination of great colors, nice shades. And so, of course, the natural color wouldn't work for them. And we developed this specifically for them, as I was saying. The tricky part coming from thermal sets is that whenever you need to pass tests like water resistance or UV resistance, you just paint the parts. And that's it, you call it a day. When we transitioned into thermoplastic, we wanted to have sustainability as a first goal. So from the bottom up, we develop a material that is first recyclable. At the end of life or scraps, you can just grind it into pellets and use it to do injection molding. So have the open doors for circularities. As well as developing with our R&D team a compound of polypropylene that passes scratch and UV resistance and other automotive interior tests.
Did you put extra layer of polypropylene just for
No, actually, it's in no formulations. It's any amount of additives
Right, okay.
on the A surface, which means that in one step, because this is thermoform, so you take the layers, you put them in the oven, 1 minute, another minute in the compression step, and then you have the final part, and it's ready to be assembled in the car, which means that you don't have to paint.
Yeah.
You don't have to do any extra finishing steps. And this is better in terms of sustainability as well as the overall time you need to spend to manufacture the part.
And one of the challenges of painting is, what we realize is every time you paint, it's like you're putting a thermoset layer onto it. So if you want to recycle it, you have a bit of a problem, isn't it?
It's a bit of a mess what happens at the end of life of painted parts.
Yeah.
Because if it's a metal part, then you can sand it and grind it down and remove the paint. But if it's PCABS or any kind of thermoplastics, I mean, most times, as you said, it's completely different chemistry.
Yeah, exactly.
How do you separate that? That is a bit of a challenge.
And painting on polypropylene, they don't really bind onto each other, so you have to surface.
Yeah, there's solutions to do that, but as I said, our goal was to avoid painting at all.
Absolutely.
Because it's, I mean, other than the fact that you have to take an additional step, you have a lot of waste in painting.
Yeah. So if we pick up the part, Ben, what we have in there is you have an absolutely gorgeous A surface here, which looks good. And then you've overmolded some parts onto it.
Yes. So in this case, the volumes were high enough to justify a cost of investments of having injection molding directly in the thermoforming step.
All in one?
All in one step.
Oh, wow, okay.
All in one step, yes. And it's very nice, like in 60 seconds. It starts from the flat parts to something that it's already cut, because it's also get cuts in the tool itself.
That is amazing,
Yeah, it is.
So you've overmolded onto it, and it's another polypropylene, I take it, so the material is compatible?
Yeah. Nice thing is that you have 3 layers here. There's the aesthetical layer, called Amplitex.
Absolutely.
It's 100% flex combined with polypropylene, so in mass it's 50-50.
Very nice.
Good ratio. Then there's an intermediate layer, which is an unwoven mix of flax and polypropylene again.
Okay.
And then you can see the stiffening layers. They took inspiration from leads, right? So it's not a different material, it's just organized in a different way. And you have local ribs stiffening the part, and without adding too much weight into the part.
100%, yeah.
And have a very good stiffness that passes requirements.
And all of that goes into the mold. Like, the engineer in me is thinking about aligning this in the mold tool, pressing it, and then overmolding around it.
That's where it gets tricky. You need a soft layer on the B side of the mold to make sure the ribs are not squeezed.
Oh, so you use some elastomeric type of...
We use silicone.
Oh, yeah.
In the end, when the part gets scrapped because the car is 10 years old, you cannot use it anymore, or you have some scraps from production, everything here is either polypropylene or flex.
Very cool.
Which means that you can grind it into pellets, and we are actively doing these R&D projects, and as soon as we have enough volumes and cars are old enough to be recycled, we can start in doing this. But you can imagine the next generation of parts in the car having back-injected parts from scraps of the previous generation.
Obviously, when you grind your material, then you're using it in fillers, in injection molding, and maybe also compression molding. You can get longer fibers in there.
Yeah, you always have to mix a bit of virgin material to make sure you have consistent mechanical performances.
Yeah.
You could think of also having recycled material as a aesthetical layer.
Yeah.
This is more of a design decision.
Okay.
Because trends are always changing, and at the moment, what's really working is showing customers that sustainability can also be nice.
Yeah.
There was this trend of a shoe made from recycled material, and they were gray with colored dots, so it really depends. Other than the technical time that is needed to do development, we wanted to make sure that everything we were doing was in line with, first of all, our expectations of sustainability and LCA goals, but also the companies we work with, like Polestar, Cupra, all the other brands. They are very vocal about the emission values and their targets.
Yeah.
And so, of course, you cannot develop a solution in 1 or 2 years that is sustainable. You're pushing the limit of engineering knowledge.
And I'm seeing a lot of CMF finishes that you have within these. I mean, you even have kind of like this blue product.
Yeah.
Is that all in mold then? Can you recycle the whole thing together?
Yeah.
What's happening?
The nice thing about flax is that once you have the yarn,
Yeah.
you can dye it as any other natural or synthetic fiber.
So the fiber is what's... Okay, so it's not the resin which is colored here.
No, I can show you some dry materials. Just give me a second. For example, this a weave. It's
So that's how it starts like,
Yeah.
right? So
is 100% flax.
Yeah.
And it's a natural color. And you can just dye it in whatever color you want. Like here it's light blue. You can also do like a dark gray color. Same as you do with our clothes, like cotton or flax or any other yarn that you have.
yeah.
This is really up to the design, color and trim preferences.
So then these teams, what they're doing is they're actually coloring these, and then straight away you have an in-mold type of coloring. So it goes straight forward. So you don't have to paint it and you don't have to do anything. That is awesome. And the recycling is completely unchanged.
I mean, you have a few percentages of pigments.
Pigment, yeah.
It can also be biosourced.
Yeah.
I mean, all the doors are open, but it's for sure way more sustainable than painting the parts or using dyes in the resin and things.
Gabriele, I'm so pleased and so excited you're sharing this with us. We're on the city. Thank you so much for your time.
My pleasure.
Yeah, it's enjoy. It's quite something to meet, thermoplastic engineers who are, know the product in and out and have a life for it. Which
It hasn't been an easy fight, but we're live and kicking.
it is not an easy fight indeed. Yeah. Thank you so much, man.
My pleasure.